lecture ka sum you should ask. The same is projected on the screen. This is the sum. Construct the Turing machine for subtraction of unary number a greater than b. If there is no doubt, one more sum we have seen. For binary number multiplied by 2 का result is displayed using this. Logic here is shifting it to left by 1 bit. So rightmost b you are locating by skipping all the zeros and ones. Rightmost b is located and converted to 0. Now the next ninth sum is construct Turing machine for finding 2's complement of given binary number. Now for the same sum we have, if you can recall, constructed. For same sum we have constructed FSM, Moore machine, that is FSM, FA with output. We have constructed Moore machine as well as Mealy machine, if you can recall. Then we have constructed PDA also. So you might get confused while this same sum is asked in university exam, because 50% of the students, they don't read the question carefully, and if the Turing machine is asked, they either draw Moore or Mealy machine or they draw PDA. 50% of the students will do this silly mistake, because this same sum appears in all the three topics. So now this is a Turing machine for finding this is Turing machine for finding the 2's complement of given binary number. Now again we will start with method 1, which you are familiar with, and then method 2, which we have learnt previously while designing the PDA. Method 1 will go traditional way, that is 011 is your input or given binary number, for which you need to find out the 2's complement. What you will do, you will take 1's complement first. So here we write, we first find, and you add 1 to above. This method everyone is familiar with, and this is what yellow highlighted is the result you will get, which says that you will get 1010, right? This is your now while designing a phase, what method or logic we have used? Scanning right end. I hope everyone remembers this. If 0 skip. If 0 skip means 0 will appear as it is from the right end, and your aim is to read the things very carefully. Let me zoom a bit. If this condition is satisfied, or you arrive at this condition, get first 1, keep moving towards left. So this is the logic we have used previously. So as per this logic, if we repeat the same sum, this is your input. Whatever is been written, let me bring it in the one screen. This is your input. What you will do, you will start scanning from the right. So this will appear as it is. उसके बाद वाला bit will also be there as it is, and rest of them will be once complemented. So here directly you are getting this answer, and as compared to method 1, these two steps are been skipped. You will find step number 1 as it is written here, and last step of the answer directly below it by using the above logic. Middle two steps are skipped. Now for this same thing, if you visualize tape, it will be likewise. We will highlight the input with yellow. Now what you want, your aim is it should be this one. This is your aim. So begin with this for logic building, and you start from the very leftmost cell, and we will point it with this arrow. The very first step of this logic says that you need to scan from opposite end. So what you will do, as this pointer is here, you will say skip, move to right. For this also, skip and move to right. Skip, move to right. Skip, move to right. You will keep on doing so till you get to the right end. How you will know that you got to the right end? Unless and until you encounter the very first B on the right end. As soon as you encounter the very first B on the right end, you will let it be B and you will move to left. So this is your pass 1. Iteration 1. Now you are to the left cell. यहाँ से what logic says, if it is 0, you need to skip it and you need to keep moving on left. So we will start pass 2 here. 0 as it is, you are moving to left. What logic says, if it is 1, the very first one from this end, we will copy it as it is. So what action will be taken for this one? Copy as it is, keep moving towards left. And now pointer will be processing this cell. Next it says, from located first one, complement each bit and keep moving towards left. So this will be complemented. If it's 1, it will be 0. Now you are at this cell, you are processing 0. Complement it, keep moving to left. You will continue the same process unless and until you encounter blank, which shows that all the input symbols are exhausted and you are done with processing of each and every symbol from the input. So, if this is B, let it be B and perform no action. So what you have done, this 0 is kept 0, this 1 is kept 1, this 1 is turned to 0. So we will now modify this step and this 0 is turned to 1. So this is your output and you got what you desired. The same. Now using this logic, and these are nothing but transition definitions, you will draw the transition diagram. So as always, we will start with Q0 as the initial state. Let me copy. O, J, and other things are understood. So what we did in very first pass, as you started from the left end in the very first pass, again you can repeat the visualization of same thing. You started from here and skipping each and everything to locate this B. So this skipping will be done with the help of self loop on Q0 likewise. Moving to right for both the input symbols. As soon as you locate B, change the state to Q1. This B is kept B, but you are moving to its left. So the action we have performed here is for all 4 cells, whereas for this B is kept as it is, moving to left. So this is your pass 1 as previously. Now pass 2 likewise. We'll start from Q1. All the zeros, if there are multiple zeros, maybe multiple zeros here, will appear as 0 only, keep moving to left. So we have written 0L for this. For this one, what we did for this one, appearing as it is, keep moving to left. This should not be in looping because it is said that this action will be performed for first one only. If second one appears, that must be complemented, and that's why we are having a dedicated line transition definition for it. The very first one, kept as it is, keep moving towards left. Left में it says that complement all of them. So this can be done on looping because the same action is there multiple zeros and multiple ones. Simply complement, keep moving towards left. You will repeat this unless and until B, capital B from the left end is encountered. As soon as you encounter capital B from the left end, means that Each and every input symbol on the tape is been processed. Now it's time to halt. So either you have this Q3 here, or you can perform no action. So this one we are writing 1n, the very first. For this we are writing 0, keep moving to left. So this becomes, and for this one also complemented n, it becomes B remains B. So this is now converted to the put on tape that provided. In case you have any sort of difficulty, you should have. Using this, now Q0, Q1, Q2 and all 4 are the states. Input symbols you will find as 0, then is 1. We'll keep 2 columns because when you enter the data here, it's a triplet. In a bracket, 3 symbols will be there. One representing next state, then representing symbol on tape, and the last one is action of read write head, whether to move to left or to right or not to perform any operation. So you are defining these transitions for 0, for 1 and for capital B representing blank. So let us now formulate the transition table from this transition diagram. So when you are in Q0, you are marking this Q0 as the initial state by using the arrow which is coming from nowhere, and this one's your accepting state, so marked as star. In Q0, we may copy this so as to reduce the efforts of scrolling. In Q0, on 0, next state you get is Q0 only, that 0 is kept as 0 only. The action is, where 3 symbols will be there if you make the entry for Q0 on input symbol 0. For 1 also, it stays in Q0. 1 is reflected as 1 only, it's not modified. Move to right. Whereas as soon as you find B in Q0, it changes the state to Q1. B is kept as it is B, and the action taken for read write head is to left. So one row of the transition table is been entered. Done with Q0 state. Now next is Q1. For Q1, the transitions on 0 and 1 are defined. So here you can say it's dash. For 0, in Q0, let me write this in some color so that you'll differentiate them as the row headings. And These are column headings, these are row headings, and this one's your set. So Q1, when process is 0, is staying in Q1 itself. 0 is appearing as 0, moving to left. Whereas in case of 1, it is changing the state to Q2, but this 1, which is the very first one from the right, is copied as it is not modified, kept as it is, it's moving towards left. For B, it is dash, it's not defined. Done with the Q1. For Q2, transitions on 0, 1 as well as B are defined. In Q2, when you are processing 0, it stays in Q2, but 0 becomes 1. It is modified to 1, moving towards left. Or 1 stays in Q2, modified to 0, goes left. Or B, now it is changing the state to halt, it appears as B, no action is performed. From halt state, no outgoing arrows are there, so everything is marked as not defined. So this will be the now complete answer for this sum, which says that you are supposed to construct the Turing machine for finding 2's complement of given number, binary number. So take a minute, go through the complete solution. We have listed, just for the sake of understanding, method 1, that this is the traditional one you are familiar with, but for designing you are implementing or following method 2. Write the logic for method 2, explain it with one example, get the visualization of input on tape, what is expected output on tape. Then with the help of this visualization, you are building this logic, which includes definition of transitions. Using these definitions, you have constructed transition diagram, and referring this transition diagram, you have populated transition table. If you feel, randomly you can take a very long binary number, and then you applying this logic, you should try finding the solution. So what it will do, if you are starting from this end, 1 is skipped, zeros are skipped, and you are moving to this B. From Q0, when you are moving towards right and encounter B, it appears as it is, you are moving to left. You are in Q1, this 1 is kept as it is, and you are moving to left. The rest of them are, so we will write output here. B appears as it is, this 1 is kept as it is, 1 is kept as it is, you are moving to left. The rest of them are 1's complement. This will appear as this is 1, this is 1, this will be likewise. Now using that traditional method, you can check whether this is the same output you'll get by that method also. So likewise, taking a random string or word also, you should show the processing using the logic for building this transition diagram. This will complete the solution. Next sum, 10th sum on design of Turing machine. Any doubt related to 9th sum, you should ask. The next sum, let me check what it is. This is for construct Turing machine for checking well-formedness of parentheses. So you are going to check whether equal number of left and right parentheses are appearing on the given input tape or not. So we start the solution by visualizing the input on the tape and output on the tape. So let us consider this is what the input is there on the tape. You need to check whether equal number of left and right parentheses are there or not. So that will mean well-formedness of parentheses. So here the logic put may the tape will be left modified. So instead of this left and right parentheses, you will find, if you are using star as the symbol to be modified, so you will find this pattern. Every time I need to press shift and reverse. You'll find this pattern something like this, and then you need to come or conclude the accepting condition for this. So instead of visualizing this output likewise, what we will do is we will start with this input on the tape, and your aim is to locate the right parenthesis first. So you say that can input as always from left by default, search for this symbol, mark it. As soon as you mark it, move towards left, search for compensating left parenthesis. As soon it is encountered, mark it. Keep into right, and so manually, if you consider this logic is followed, So you will be starting with this left end. Is it a right parenthesis? No. Move to right. This is also not. Skip, move to right. As soon as you find this one, let me copy the logic. Two cells. So here we can write the action that this is skip, you are moving to right. For this one also, skip moving to right. As soon as you find the right parenthesis, mark it, move to left to find the compensating left parenthesis. This is your pass 1. Left में you what? Compensating left parenthesis. So this will also be marked. You are moving to right. Ends your pass 2. यहाँ पे you got star. It's marked. This one is also marked. Pass 3 starts from here. All the marked symbols you don't need to process, so you will keep them as it is and you will keep moving to right for the search of right parenthesis. So in part 3 you say that let it be star, move to right. If it is left parenthesis, you know you need to skip it. If it's right, mark it, move to left. So this will be converted to star. This ends your pass 3. Moving to left. Start of pass 4. Left में as soon as you encounter compensating left वाला parenthesis, that will also be marked to right. So this will get converted to. I hope the things are understood. You are advised to do the same, follow the process with pen and paper at your end, or else the designing will be never understood. Moving to right in search of right parenthesis. Process symbols are simply skipped. So this will be your pass 4. Here will be included in pass 5. Moving towards right. Mark this. This ends pass 5. Start of pass 6. Mark symbols left. Now in some cases, if it is star, we are keeping it as a star moving to right. But when you are coming back on the return path, star is kept as it is, but you are moving to left. So this is the difference. So paths will change. You won't be following the same paths because they are directed. Aim is to locate left वाला parenthesis. यहाँ पे skip this, keep moving towards left. Skip this, keep moving towards left. As soon as you encounter, mark it, move to right. So this ends your pass 6. अभी as soon as you have marked it, ये भी मार्क हो गया था, बट टेप का as in whole टेप का visualization is not possible to read write head, only one cell is visible. So abhi 6 cells are visible to us, and we know that each and every input symbol is been processed and converted into tape symbols. But for read write head, only one current cell will be visible. So read write head is not aware that all the symbols, input symbols are been processed and no more input symbol is there to process. So it will keep moving towards right. It will continue past 7 and it will try to define the accepting condition. So it will keep moving to the right in search of right parenthesis, but it is finding only processed symbols. So it will keep moving to right, and this will be done till this B is encountered. Here also skipped. Next symbol is also skipped. Expecting right parenthesis, but it is not finding the right parenthesis. Rather, processed symbols are encountered. B was not at all expected, but it encountered B. It will be kept as it is. It will move towards left. Again, to make sure that nothing is there in case it is not well formed, unbalanced string of parentheses, single left or right parenthesis will be left on the tape. So to make sure that there is no such case, it should again make one last pass. In that pass, if nothing is processed and B is encountered, it will stop. So here also it will say that if it is start, let it be start, keep moving towards left for all of them till this B is encountered. That will be accepting condition. It will go to halt state. So here logic says these 3 points. Using these 3 points, you will be building the transition diagram. So let us start in Q0 as always. And to avoid scrolling back and forth, we will copy this once again, and then using this visualization we will keep adding transition to this transition diagram. You started with leftmost symbol here, which is skipped. So all the left brackets are skipped. Multiple left brackets can be there. So you are adding, if it is left bracket, let it be left one, keep moving to R. So we are using loop for it. Second left bracket is also skipped. You are moving to R. As soon as you encounter right wala bracket, you will change the state going to Q1. Action taken for this is market. Any other symbol can also be used, but you make sure that now you will move towards left to search for the compensating left parenthesis. So this goes likewise and goes. Now you are performing the same action, but when you are in Q1. So in Q1, if you are encountering immediately the compensating left parenthesis, you will perform action that this left parenthesis should also be marked. And now keep moving to right in search of next right parenthesis. So this is Q2. So ये वाला is converted into star. Moving to right. Right में when you are in Q2, you encountered star. So if there are multiple stars, them simply skip them. So multiple stars can be there. We are having for that purpose a loop on Q2. So it says this star is kept as it is, moving towards right. Whether now same process will be followed, right bracket is kept. So if we come back to Q0, likewise if we come back to Q0, let us flip this. So what this is saying, if it is left parenthesis, be left, moving to right in search of right parenthesis to strike off or mark. Q1. Q1 में if there is one more left parenthesis that will be skipped, it will move to right. You are in Q1, you encountered right parenthesis. What it is doing? It is converting it to star and then will move to left. So let us convert this to star, move towards left. You are in Q1. Q1 में you encountered left parenthesis, mark it star, move to right. You are in Q2. Q2 में you encountered star, star is kept star, it is moving to right. Now it has encountered right parenthesis. Whether the right parenthesis का transition is defined here? No. Left parenthesis का we have defined. So you are not expecting right parenthesis in Q2. So at this junction, where you should be as soon as you encountered right parenthesis? Q0. So here, what transition now we need to add? यहाँ पे हमने क्या किया? As soon as we have marked left parenthesis, we have converted into star. We are moving to right in a search of right parenthesis. Yes, this is okay. So if right parenthesis is immediately found, that should be converted into star. So this transition is already defined here. So in Q2, we will add the transition If it is right parenthesis, mark it and move towards left. Check for compensating left parenthesis. This will be your Q3. Now again, this path can be you are converting this to star, you are moving to left. On the way, each and every star will be skipped. So यहाँ पे if we add, if it is star, let it be star, moving towards left. In between, when we are moving here towards left, whether we should encounter this, yes, यहाँ पे we should encounter somewhere here. Now we are skipping this star and then we are supposed to encounter left parenthesis here. So transition of this, what to do for left parenthesis is already given in Q1. So instead of having loop here, what you can do is you can connect this state here. Let me stretch it a bit so that the transition below it will be visible. And here you can say if it is star, let it be star, keep moving towards left and if we shift this loop from here to this place, that this will be more suitable. That in Q3 कहाँ पे आपको मिला? As soon as this right parenthesis is converted to star and you are moving to left. So this is converted to star, you are moving to left. You are in Q1. So Q1 में there is a loop to skip star, keep moving to left until you encounter right parenthesis. As soon as this right parenthesis is encountered, that will be converted to star. You are moving to right. You are in Q2. Right में all the stars are skipped. Keep moving to. In Q2 you are encountering this B. So यहाँ पे as soon as you encounter B, if you say you will again make a pass towards left end to make sure that now no input symbol is left on the tape. So you will say in Q2 if you encountered B, let it be B, keep moving to left. And here you can have a self loop to skip all the stars, keep moving to left. While moving to left, without processing any input symbol, if B is encountered, means equal number of left and right parentheses are being encountered and they have been striked off. So now you can have a state fault here. One more time, if you encounter B, let it be B for no action. One more time you need to revise this for some other string, and then you need to adjust the transitions. It might be the case that you need to adjust one or two transitions and states and these loops. So main logic for this is, scan the input on the tape from left hand, search for the first right parenthesis encountered, mark it. As soon as you mark the right parenthesis, you keep moving towards left to search for compensating left parenthesis. As soon as you are in the cell with the left parenthesis, that will also be marked and you will repeat the process. So let us take a different example. And try to process this string using the Turing machine. So try to just visualize it using this Turing machine. Simultaneously try to draw this. So now I will say that I am skipping on the left parenthesis, or stress it here. I am skipping this left parenthesis. I am skipping this left parenthesis. I am skipping this left parenthesis. I am moving to right. I am still in Q0. Again I got left parenthesis, skipping. I am in Q0. Moving towards right. In Q0 I encountered right parenthesis. I am converting it to star. I am moving to left. Left में I encountered left parenthesis in Q1. So that will be converted to star. Moving towards right. You are in Q2. Star is encountered. You are skipping it. You are moving to right. Right में you got right parenthesis. Right parenthesis should be converted to star. Move to its left. You are in Q3. Q3 में star is skipped. Moving towards left. You are in Q1. Star is skipped. Moving towards left. You are in Q1. You encountered right parenthesis. Left parenthesis. Left parenthesis is marked as star. Moving towards right. You are in Q2. Q2 में you encountered star. Skip it, move to right. Q2 में again you encountered star. Skip it, move to right. Q2 में you encountered star. Skip it, move to right. Q2 में you encountered right parenthesis. Convert it to star. Keep moving to left. Q3 में you encountered star. Keeping moving to left. You are in Q1. You encounter star, skipping, moving to left, skipping, moving to left, skipping, moving to left. You encounter this left parenthesis, which is converted to star and moving to right. You are in Q2. Star is skipped, moving to right. Star is skipped, moving to right. Star is skipped, stay in Q2, moving to right. Star is skipped, stay in Q2, moving to right. Now you encounter B in Q2. As soon as you encountered B in Q2, you keep B as it is, move to left. You are in Q4. Q4 में you encounter star. You skip all the stars, you keep moving to left. But in Q4, you encountered left parenthesis now. So for Q4, you are not expecting this left parenthesis. So you are stuck in Q4 and you are not reaching to halt because this was the case of unbalanced parenthesis. So you take one more example and try to trace this. We have taken the case of unbalanced parenthesis. So you are stuck in Q4. Take one more example of say balanced and try to trace it. You should be able to reach halt state in case of balanced parenthesis. If at all some modifications are required, you will add or delete. Any doubt related to this? Turing machine for checking well-formedness or well-balanced parenthesis. This is asked in two types. Construct a Turing machine for checking well-formedness of parenthesis or well-balanced parenthesis. Take a minute, go through this diagram. In case you have doubt, the mics are provided. Let me share